Hello class, now we're looking at section 3.7, and remember 3.7 was about variation problems, and they're fairly straightforward. We did basically the whole front page of the section 3.7 handout, so what I'm going to do is I'm going to work on the ones from the back page that we did not do. So I'm going to start with number 10, okay, and get out your 3.7 handout and read along with me. It says the amount of paint needed to cover the walls of a room varies jointly. Okay, let's start there. The amount of paint, okay, I'm going to use A for amount of paint needed to cover the walls of a room varies. As soon as I see varies, I say equals and I put K. Remember, it was called the constant of proportionality. Okay, it varies jointly. That means I'm multiplying whatever comes up next as the perimeter of the room, perimeter's P, and the height of the wall, height is H. Okay, there it is. That's the first step to write that general equation. The amount of paint needed varies jointly as the perimeter and the height. Okay, now we're going to fill in the first set of numbers they give us. They say, let's see, a room with a perimeter of 65 feet and 8-foot walls requires 5.2 quarts of paint. 5.2 quarts? I don't think this is very accurate. Okay. Find the amount of paint needed to cover the walls of a room with blah blah blah. Okay, so now I have these numbers and I am able to figure out what K is. So I'm going to go over. You can do this on scratch paper or however you think would work best for you. And I get 0.01. K is equal to 0.01. That's interesting. Okay, so now I'm going to write what I'm calling my, let's scoot over here, formula. So this is the formula that you use or would use to figure out how much paint to buy. Okay, remember this is not a real formula. This is completely inaccurate, but let's pretend. So it says find the amount of paint needed to cover the walls of a room. Okay, I'm looking for the amount of paint needed. I know what K is. That has a perimeter of 35 feet and 6-foot walls. Okay, so we're going to do the math and we're going to say times 35 times 6. It says 2.1, and that would be in quarts. You would need 2.1 quarts of paint. Okay. Number 11 we did in class. So please look back at your notes for that one. And let's do number 12. I think we did, well, let's try it again. Let's do number 12. Okay, number 12, let's read it together. The pressure of a gas, okay, that's P, varies, equals K, jointly as the amount of gas measured in moles. The amount of gas measured in moles. So I saw lots of different letters out there, so I'm going to put A for amount. And the temperature, and inversely, oh, that means I'm dividing whatever comes next, as the volume of the gas. Okay, there's our first step. That's the general equation. Now let's plug in the numbers they give us. If the pressure is 1287 kilopascals, when the number of moles is 4, the temperature is 330 Kelvin, and the volume is 320 cc's, find, oh, let's stop. Okay, now I'm going to use this to figure out what K is. Okay, so I'm going to use my handy calculator here, and let's see. I take 1287 and I multiply by 320, and then I divide by 330, and then I divide by 4. And I get 312 for K. Okay, now I'm going to write my formula. So my formula is the pressure is equal to 312 times the amount of gas in moles times the temperature in degrees Kelvin divided by the volume in cubic centimeters. Okay, there it is. Now let's answer the question. Let's go to that find part again. Find the pressure. So we don't know pressure. We know K is 312. Okay. When the number of moles is 6, the temperature is 270 degrees Kelvin, and the volume is 360 cc's. Okay, and then once again, you just use your calculator. Times 6 times 270 divided by 360. Okay, I did something wrong. This is why calculators are sometimes more trouble than they're worth. If I wanted to think about it, I could do some canceling here and think about stuff. No, that's the number. There we go. I'm getting 1404, and the units on that would be kilopascals. Kilopascals. That's a pressure. Okay? Alrighty. So now you guys did 13 in class. I remember that. And we did 14 together. And you did 15 in class. 15 is very similar to what we just did. Okay? Temperature and inversely. Yeah, it's the same as the one we just did, so I think you guys can handle that. And now let's do 16 together. Okay, let's do 16. And this is the last one. The body mass index, or BMI. Okay, we all know the dreaded BMI, right? Takes both weight and height into account when assessing whether an individual is underweight or overweight. BMI varies, so BMI equals K directly as one's weight in pounds, so we'll put W for weight, and that's in pounds, and inversely as the square of one's height in inches. In adults, normal values for the BMI are between 20 and 25. Okay? A person who weighs 167 pounds, so we got K, the weight is 167 pounds, and is 69 inches tall, has a BMI of 24.66. Okay, let's figure out what K is. Okay, so let's see. 24.66, and then divided by 167. Oh, it helps if I do 167, huh? Did you guys get 703? I better double check that. Okay. 69 and square it, and then multiply by 24.66, and then divide it by 167, and sure enough, about 703. So the BMI formula is about, your BMI is equal to 703, I'll put a squiggly there, about, times your weight in pounds divided by your height in inches squared. Okay? Now, what is the BMI to the nearest tenth for a person who weighs 130 pounds? Okay, we want this person's BMI, 703. He or she weighs 130 pounds and is 64 inches tall. That's about 5'4". So 5'4", 130, that sounds like a pretty healthy person to me. So let's try it. I got 22.3. The BMI of this person is about 22.3. Okay, this is a very healthy person. Now, if everyone wants to be depressed, you now have a formula to figure out your own body mass index. Okay, so that's it for Chapter 2, and I hope this was helpful.